Alright, today we will continue our discussion of logarithms and we'll expand upon that. So let's see how we do. So we're going to another level today, a level where we will not be using the calculator, or certainly not a TI-30XS multi-view, maybe a 4-function calculator if you need it. Instead, we will be using a chart like this one. So you will have access to this, but do not use your scientific features on your calculator, please. Alright, if you have a pencil in your hand, put it down. You know better at this point. Watch me and then go back and do these problems yourself. Do not copy off me. Put the pencil down. Okay, so by now you understand that logarithms are exponents. What exponent are they? A log is the exponent that changes the base into this other number. So in other words, you should be asking yourself the question, 5 to the what power is equal to 125? And whatever is the answer to that question, that is the value of the log. Alright, it's that exponent, the question mark. And I know that 5 to the third power gives you 125. Boom. So that means the answer is 3. Please notice the answer is 3. Do not give me 5 to the third power equals 125. Don't give me the whole equation. Just 3. That's it. Okay, number 2. What's the exponent that changes 7 into 343? Alright, 7, 340, that's also 3. Boom, that's it. What power changes 8 to a 1? Well, okay, 8 to what power gives you 1? That's weird. Oh yeah, that's right, 0. Because anything to the 0 power is 1, right? 8 to the 0 power equals 1. So, the answer is 0. Alright, number 4. This is going to be 1. Alright, 12 to the 1 power gives you 12. Alright, this will be 2. The power that changes 6 into 36 is 2. Alright, there's not much to explain on these problems. This is also going to be 2, because 4 to the second power gives you 16. Alright, number 7. Okay, slow down, slow down. This one is slightly different because notice we're going from a larger number to a smaller number. So we're still asking ourselves the question, 4 to what power is going to give me 2? So how in the world are we going to change a bigger number to a smaller number with a power? Well, the answer is fractional exponents. Please remember this. In order to do this problem, I need you to remember that fractional exponents are roots. For example, the 1/2 power is the same thing as square root, and so on. 1/3 power is the same thing as cube root, and 1/4 power is the same thing as the 4th root. So, if I want to use an exponent that's going to change a bigger number to a smaller number, for example, if I do 16 to the 1/2 power, that's 4, because that's the square root. If I do 8 to the 1/3 power, that's 2, alright, because that's the same thing as the cube root of 8. And if I do 16 to the 1/4 power, you know what, let me do a different one, because I already did that. If I do 81 to the 1/4 power, that's 3, because that is the, if I do the 4th root of 81, that's 3. Okay, so just keep that in your mind. So the bottom line is, if I need to change a bigger number to a smaller number, think fractional exponent, because those are roots. So since I need to do the square root, That would be the 1/2 power. So the answer number 7 is 1/2. Okay, now back to normal. 7 to what power gives me this? Okay, I've got 7, and there's my 2401, so that is the 4th power. So 4, kabam. Okay, now here's one that's slightly different. I've got this fraction going on. Now here's what I recommend as a shortcut. If I were you, when you see a fraction like 1 over something, I would temporarily scribble out the 1 part and solve the problem as though this is what it were. This is what it was. So 6 to the what power would give you 36. Alright, you're probably thinking, oh, that's 2. Alright, 6 squared is 36, so that would be 2. Now, because it's actually 1 over the number, then that makes this a -2. Okay, and I'll show you why. So here's why it works. I mean, that's the answer. But the reason why it works is, so we were asking ourselves 6 to the what power? If we do 6 to the -2 power, remember what a negative power does? It drops you down to the denominator. So this would be 1 over 6 squared, which would be 1 over 36. So that's why when you have a fraction, it's probably going to be a negative power, because that's what drops you down to the bottom. Alright, but we don't need all of this. Okay, number 10. Alright, we'll do that fraction deal even when the fraction is part of the base. So using the Burton shortcut, I would recommend, alright, scribble that out. Just answer the question as though it were 5. So what power turns a 5 into a 25? Well, that would be 2. Okay, 5 squared gives you 25. But because it really was 1 over 5, let's go with -2. So I'm thinking this is the answer. Now let's just check it. So if I have 1/5 to the -2 power, well, a negative power on a fraction, you do the reciprocal. So this would make 5 over 1, or just 5, squared. And then 5 squared would be 25. So this is the power that changes that to that. And that's how I would do it if I were you. Okay, this one. Again with the fraction. So let's scribble this out. Alright, now this also involves the other thing. Notice we're going to a bigger number to a smaller number. So the answer is not going to be 2. It's going to be 1/2. Okay, because think square root. To get from 16 to 4, we need the square root. But the square root is the same as 1/2 power. But since it really was 1 over 4, then that'll be a -1/2. Okay, and let's check our answer. Okay, so supposedly this power will turn 16 into 1/4. So let's see, 16 to the -1/2 power. A negative power drops you down, so this would be the same thing as 1 over 16 to the 1/2 power. And 1/2 power is the same thing as the square root. So this would be 1/4, just like we wanted. Okay, number 12. Okay, listen, the shortcut for a problem like number 12. Notice that both of these are bases. Log base 4 and then 4 to a power, that's another base. When you have a log base and an exponential base, they are inverses, okay? They undo each other. So I'm just going to have -0.38. Okay, these cancel each other out. They are inverse operations. So that's it for that. Watch out for the base and base being the same. Alright, number 13. Same deal. Log base, exponential base, those undo each other. So I'm just going to have 7y. Okay. Now this one, I can make problem number 14 look like number 13. Because 9 is 3 squared, right? So I could rewrite this problem as log base 3 of 3 squared, and that x is going to still be there. Now, log base 3 and exponential base 3, they cancel each other out. So that's just going to leave me 2x as the answer. Okay, now this one, 256 has to turn into a 4. Okay, so I'm thinking fractional power. It's getting smaller. So let's look at the chart. How do we turn 256 into a 4? Okay, so 256. Alright, so 256 is 4 to the 4th power. So if I do the 4th root of 256, that will give me 4. It's going backwards. Okay, so that's why it's going to be 1/4. Okay, so in other words, 256 to the 1/4 power is going to give me 4, because that means the 4th root of 256, which is 4. Alright, so 1/4. Alright, I've really got to do some of these fast because we have so many problems on this assignment. Okay, number 16. 5 to what power gives me 625? 4th power. Okay. Alright, scribble out the 1 temporarily. 4 to what power gives me 64? Well, that's 4 to the 3rd power. So at first I put down a 3. But then because it was really 1 over, then it must be -3. Okay, what's the invisible base here? It's a 10. Alright, so 10 to what power will give me 100,000? Well, count the zeros. 1, 2, 3, 4, 5. So 5th power. I mean, it's on this chart also. So 10 to the 5th power, that's 100,000. But you count the zeros. Alright, so it's 18. Alright, 19. Again, when you see 1 over something, scribble out the 1, do the problem, and just make it negative. So 2 to what power would give me 16? Well, that's 2 to the 4th power. But because it's really 1 over 2, then it must be a -4. Okay, I think I'll just check this one just to demonstrate further. So this really is working because 1/2 to the -4th power. Negative power, you do the reciprocal. So this would be the same thing as 2 to the +4 power, which is in fact 16, which is what we wanted. Alright, number 20. Alright, what power would turn 216 into 6? It's getting smaller, so it must be a fractional power. So we must be going backwards. Alright, so we need to turn 216 into 6. Okay, so there's my 216. So the cube root of 216 would be 6. So in other words, if I were to do 216 to the 1/3 power, that's the same thing as cube root, that would give me 6. So the answer is 1/3. Alright, do not give me this whole thing, just give me the 1/3. Okay? Okay, when you have these decimals, change this to a fraction before you do the problem. Remember your place value. First is the 10ths place, next is the hundredths place, and next is the thousandths place. So this 4 is in the tenths place. I'm sorry. This 4 is in the hundredths place. So 0.04 is the same thing as 4 hundredths. And let's reduce that. Okay, so dividing both of these by 4, that gives us 1 over 25. Okay, so this problem really becomes log base 5 of 1/25. So, like I've told you in other problems, I would scribble out the 1 and ask yourself, 5 to what power gives you 25? Clearly that's 5 squared gives you 25. Because it was actually 1 over the number, then a negative 2 should do the trick. That will drop it down. Okay, number 22. Okay, now we're on the back. Rewrite each equation in exponential form. Find the value of n. Okay, exponent form. This is in an invisible base 10. I always like to start with the base. Okay, so base 10. When I do exponent form, these two things should switch sides. So this n is going to come over here and become 10 to the nth power. And this 10,000 is going to go over here. So 10,000. Okay, now I got to ask the question, 10 to what power gives me 10,000? Well, I could just count the zeros. 1, 2, 3, 4. So that's going to be 10 to the 4th power would do this. So n is 4. All right, don't skip this part. You have to show the equation in exponential form. So this one, I already know from this form that the answer is going to be 2. Okay, because 13 squared is 169. But let's write it in the other form. So starting with the base, why did I put 10? Starting with the base, I've got 13. These two guys basically switch places. So 13 to the n power is equal to 169. So 13 squared, okay, so that's going to be, that means n is 2. Okay. So this is going to take a little work. Rewriting it in the other form. So I've got 20 to the n power, okay, is equal to 400. Okay, it's not going to take a little work. N is 2, all right, 20 squared. Now, even if you, say if you didn't know that off the top of your head, because maybe you didn't, you know, I'm not going to judge. Now, you're not allowed to use a TI-30, but I will let you use a 4-function calculator. So you might just experiment, you know, multiplying 20s together. And the first thing you try would be 20 times 20. And right away that's 400. So you know that's 20 squared. So n is 2. Alright, 25. Natural log, ln, stands for natural log. Alright, that means it's understood to be log base e. That's what's happening. So if I write this in the other form, start with the base. Okay, so here's my base. I just bring down the base, and that's e. Now these two things are going to basically switch sides. So this will be e squared, and then n will be over here. So n is equal to e squared. Now, if you're not going to have decimals, then, you know, this is actually a valid answer. N is e squared. Boom. It doesn't go any further than that. And in fact, if you don't have a calculator, a scientific calculator, you can't go any further than that. So I'm just going to leave it like that. n is equal to e squared. Alright, anyways, writing this in the other form. Let's start with the base. The base is 3. So bring down your base. Now these two things should switch sides. So this will be 3 to the 4th power is equal to n. Alright, 3 to the 4th power is 81. Okay, you can get that off your chart. 3 to the 4th power, 81. So this one, 2 is your base. Always start with your base. Drop your base down. Boom. Now these two guys are basically going to switch sides. So this will be 2 to the 5th power is equal to n. 2 to the 5th power. So n is equal to 32. Alright, rewriting this in the other form, we've got, always start with the base. Just bring your base straight down. So there's my base of 2. These things we're basically going to switch sides. So this negative 3 is going to come over here and become 2 to the negative 3 power. My n is going to go over there. So that means n is equal to. Now this negative drops you down. So this will be 1 over 2 to the 3rd power. 2 to the 3rd power is 8. So this will be 1 over 8. Well, that's a terrible n all of a sudden. Let me see if I can do better. Okay, that's a little better. So n is equal to 1/8. Number 29. Start with your base. Drop that base straight down. Now these two guys are going to basically switch places. So it's going to be 5 to the negative 4 power equals n. Again, that negative just drops you down. So that's 1 over 5 to the positive 4 power. Let's see, 5 to the 4th power is 625. So this is going to be 1 over 625. Okay, number 30. N is already by itself, but we'll follow the direction. So we're asking ourselves how 16,807 becomes 7. Clearly this is going to be a root type of a situation, so that means some sort of a fractional power like square root, 3rd root, 4th root, 5th root. It's going to be one of these. But first let's rewrite it. So start with the base. The base is 16,807. That's the base. Alright, so these two things are basically going to switch places. So it's going to be this to a power is equal to 7. Okay, so we really can start with the 7 and then look over. Okay, so 16,807, it's right there. See the 5? That means the 5th root, if I go backwards, the 5th root of 16,807 is 7. So we need the 5th root. So that means that n is 1/5. Okay, so that's number 30. Looking kind of ugly. Alright, let's write it in the other form though. So start with your base. So the base is n, so I just drop that straight down. These two guys are going to switch places. So I'm going to have n to the negative 3 power is equal to 1 over 125. It'll make me feel better if I make these look more the same. So that negative 3 power, that drops you down to the denominator. So this would be like having 1 over n to the positive 3 power. And then 1 over 125. Well, look guys, can you see that these two parts are going to be the same? I've got 1 over this, I got 1 over that. Alright, that tells me that n to the 3rd power must equal 125. So what to the third power gives you 125? Okay, third power, 125. Oh, look, 5 to the third power is 125. So that means n must be 5. Okay, genius. 32. Rewriting this in the other form. Oh, and we've got the 0.00 business. What should I do first? I think I'll deal with the whole decimal thing first. This is, so I've got tenths, hundredths, thousandths, 10,000ths. This is the 10,000ths place. So this is the same thing as 1 over 10,000. Okay? So, let's do it though. So what we're going to do is start with the base. The base is n, bring that down. So there's my base. Now these two things need to switch places. So this -4 is going to come over here and become the power. This fraction is going to come over here and be 1 over 10,000. Now this is the same thing as 1 over n to the 4th power. And here I've got 1 over 10,000. Okay, that means these two denominators must be equal. So, 10,000 must equal n to the 4th power. So what to the 4th power gives you 10,000? I bet you can guess. Okay, 4th power, 10,000. Oh, look, 10. 10 to the 4th power gives you 10,000. Okay, so that means n is 10. Okay, looks like we're down to the last problem. So, what's the invisible base here? That's base 10. So start with the base. Drop that base down. 10. Alright, now these two guys are basically going to switch places. So I'm going to have 10 to the 7th power, okay, is equal to n. So n is 10 to the 7th power. Okay, that is off of the little chart here. I've only got up to 10 to the 6th power, but as I've pointed out to you before, the power matches the number of zeros. See, 2nd power, 2 zeros. 3rd power, 3 zeros. Alright, 5th power, 5 zeros. So, guess what? 10 to the 10th power is going to be a 1 and 7 zeros. Okay, so that's 10 million. Alright, and that is it for this assignment, this lesson. Peace out.